All right. So let's see. New pull requests for this week. I've got a couple. Both. One is actually replaced by the other, but this is very much all related to the Blue Store caching. I'll talk about that maybe a little bit later. But the good news is that it's a pretty big improvement. Hey, Sage. Sage, do you want to go over the pull requests? Oh, I can't hear you. I think you're muted.
Do you have the pad URL? It's been a while. It's not in
Yeah, sure.
pop-up history.
There we go.
All right. Let's see. There's your pull request. That's refactoring the caches. Looks excellent. There's a second one
That's
the same, right?
Yeah, it's just
Replaced by,
the trim
okay.
piece of it. Yeah.
Right. I haven't looked at this one from Jason. But that sounds good. Improving the journal performance. Let's see. There's a small optimization objector that merged. There's also this PG mapping cache, which merged last week, I think, which is nice. It just basically keeps in memory all the crush calculations for a given OSD map that won't have to repeat them. And it shows a noticeable improvement. I can't remember if it's like 10%, 20%, something like that. Yeah. But I think that's especially important for Flash clusters. This one bumps up the priority for recovery ops if they're triggered by a client op. Surprised that we weren't doing that already. I think that was an oversight. And then Igor finally addressed an issue. With Blue Store and some weird extreme cases. It could run out of IDs for shared blobs. And so it basically notices that and cleans up when that happens. Bit of an awkward one to fix, but finally got sorted out. I haven't looked at this objector stuff from Adam in case this is all stuff refactoring librettos so that it'll tie in closer, more appropriately with RGW. This opcrate one I think is about to merge. It's an optimization for the case where the OSD knows that the object doesn't already exist and can therefore skip a lookup in Blue Store. So it's a slight improvement. The OSD just has to be more careful about how it crafts transactions. This garbage collection, I think that's the other one. It's the same as the one above. Yep. Yeah, I haven't looked at Adam's thing. Looks like the MDS cache memory limit changes are in progress. Is that the same as the MDS memory target? Not sure about that.
Yeah, I think so.
Okay. And there's this POC from Roman, I guess his name, and that one I think needs review. I think that PR just got resurrected with the new discussion. Yep. I guess that's it for the new stuff. Crimson things down here. Adam's still working on sharding Blue Store, RxDB, multi-site sync fairness, U-ring. Yep, that's it.
Cool. All right. Well, if
Yep.
well, maybe I'll see. Does anyone have anything they want to talk about this week? Otherwise, I got some stuff.
I have something.
Go for it.
This is Mohammed. It's about, again, the LTTNG stuff that I revived. I hadn't touched it in a long time. But now that I've had a cluster to benchmark it, I ran some benchmarks on BlueStore 2020 with various queue depth. And if I can just share my screen quickly, do you mind?
Go for it.
Go for it. Yeah.
So basically what I've done is that I have all-flash cluster with 5 nodes, 5 OSD nodes, and I cranked up the debugging to 2020 for BlueStore only, and so that is the baseline. And I changed the code of BlueStore. Basically, all log statements I converted them to LTTNG trace points, and I ran for multiple queue depths. So I have QDF ranging from 1 to 128, and basically, here's what I got. I'm looking at IOPS and the latency. And for queue depth, well, basically, when IU depth increases, you can get a lot more IOPS with LTTNG compared to, well, Ceph here is the, Ceph baseline thing. So it's really a major performance difference. It's about 20%. So that's for 4 megabytes and 4K chunks. It's really significant. Yeah, and if I'm looking at the tail latency, basically, see how much of a difference that makes. So basically, writing to a file, really, the tail latency is huge with the out, basically, compared to LCNG. What I think this tells us is that, since well, first of all, the fact that the difference is really with the larger queue depth is, I imagine, with the larger queue depth, more threads are involved on the OSD nodes. So there's probably more contention somewhere, right? The fact that multiple threads for each OSD are writing to the same file on disk, there has to be a lock somewhere, right? Or some sort of contention.
I've definitely seen contention on the logger lock when we have like a lot of debug output. It's like huge.
Yeah, exactly. Well, LTTNG is per CPU, so you don't have that. Anyway, again, this is just for BlueStore 2020, so it's not something that people are usually running. Otherwise, for log level of 0, 1, 5, there isn't really much of a difference. Because, sorry, this is just the tracing infrastructure. There's the whole, string converting strings and string copying and string manipulation. This is something else, and I'm pretty sure that has to be addressed somehow. Because even with LTTNG, I'm still using strings. So all objects they have the string operator, and they are converted to strings and copied. So that overhead is both in LTTNG and in the baseline. But I'm talking about the actual tracing mechanism and buffering in memory. This is what this graph shows, basically. So I definitely think there's something to do there. Honestly, Mark and you and I, we've talked about this. I don't know if you're really using LTTNG is the right approach, because there's a lot of overhead for the developers and not as easy as just a D-out statement. It also adds a dependency on LTTNG. The LTTNG daemon crashes, then you have no more logging, etc., etc. So there's definitely more overhead. I don't know if it's worth it. I don't think it's really worth it. It's because it's only the 2020 case that is affected. But anyway, if you have any thoughts on this.
I guess my thought, I guess, first would just be that at least it showcases that there's big gains that we can make, right?
Yeah. Yeah, exactly. That was really the takeaway for me. I don't. I mean, we can talk offline and maybe on the PR if you think using LTTNG is the right way. But if not, then maybe reworking the DL infrastructure. I mean,
Yeah.
clearly that's something that can be done.
Do you have the pull request of the conversion for BlueStore? We can look at it.
Uh, I haven't opened it yet. I only have the very old one that is open, and I've reworked it all out. I'll update it and email it to Ceph. Does that work?
Okay. Yeah, that'd be great. Thanks.
Cool. Awesome. Well, that's it.
I mean, I think it seems like the ideal situation would be if there's a translation on the code that changes the debug statements to trace points that still lets you use either the old dout infrastructure or LTTNG, via like a compile option or something. So that
Yeah, I mean that is one of the alternatives that I've worked with, which is pretty much it has the simplicity of the out and
yeah,
LTNG, but okay, when I send you the pair, it
yeah,
will be a little bit more
yeah. Okay.
clear.
Okay.
Sage, one of the things we've talked about in the past too is like maybe having more developer-oriented logging that's in like a
Yeah.
binary log format that's per thread,
Yeah.
and then
Yeah.
splitting this kind of stuff off so there's no locking anymore and it's
Yeah.
no string manipulation, all that stuff.
Yeah, I agree.
All
Yeah.
right, thank you guys. I'll send the email.
Yeah, I mean, I think that the piece that's sort of missing from that picture is what the default level is with debug 0 or 0.5 or whatever. Like
Yeah,
it's
I did
20%
not talk
faster, but
about.
if it's only a quarter as fast as it was originally, then like it doesn't matter that it's 20% faster.
Yeah.
Yeah,
Also really curious what
I
ends up
don't have the
looking like
graph.
when we do have the string overhead out of there.
Yeah, right. Yeah, that's the real.
Yeah, again, the benchmark that I ran for the default, it wasn't really significant, honestly. Even on an all-flash cluster, for the default log level, it's not worth it to change more than
Yeah, right, right. It should be noticeable.
cool. Well, thank you.
Yep. All right. Cool.
All right. Anyone else have anything this week that they'd like to bring up?
Um,
Sorry, did someone say something?
I could have sworn there was something that I thought of a minute ago, but now I forgot it. So I guess not.
Okay, yeah. Write it down if you think about it. I'll start in on some of this other stuff then. And so I wanted to just talk a little bit about the BlueStar Cache refactor PR. So it's funny. When I started this, I didn't even really performance was kind of a secondary thing. I was really only trying to make it so that the buffer cache was behaving a little bit nicer and not exceeding its allocation. But I kind of wondered if there might be some benefits to it. So anyway, I started working on basically changing the way that the cache works so that we trim whenever we're adding data to the cache rather than when we are just in like a loop in the mempool thread. And that took surprisingly long to actually get working right, but I got working in the end. And it helped pretty dramatically. I think basically from looking at wall clock profiles and doing lots of testing on it, the benefit here is that we have far shorter trims. We're not locking as long, holding the lock as long in the mempool thread. And we have fewer locking events overall anyway, because we're just taking locking away. And in anywhere else where we're doing trim, we've already grabbed a lock. So less locking, less contention on locks, good overall. When I did that, what I saw was that performance improved, but actually lock contention went up. It was weird. the reason I think lock contention went up is because the buffer cache basically adding buffers for the buffer cache and looking up O nodes in the TP-OCTP threads were contending with each other. So, when you're adding buffers, that's happening in like I think the KV sync thread, if I remember right. In the finalized thread. And I wanted to see whether or not basically splitting those apart would improve things further. So that's what the second part of this PR does, is it basically rips the cache apart so that you have independent buffer and O-node caches that don't share a lock anymore. So they each have their own independent lock. And that improved dramatically. Much, much less lock contention. All of this overall is improving tail latency pretty significantly too. It's like half the tail latency, a third of the 99.9th percentile latency for IOs. So it was really good. It worked out even kind of better than I had expected it to. One thing I did notice is that after doing all of this now, in 4K random writes, I actually see PG lock contention where I didn't before. So now it's like maybe 3% of the time spent actually in PG lock on 4K random writes. So kind of neat, I guess.
Yeah, I think this is awesome. That's sort of a facepalm moment when you split out the buffer and O-node caches because they really aren't related.
Yeah, exactly. I know. I was like,
So that was good insight there. Yeah, sounds great. I think we tagged it for needs QA. Sure, but should definitely get that merged.
Yeah. And I know there's a couple of nits in there, and then Igor was wondering if I was being a little overly aggressive on trim in a couple of places, so I'll take a look at those comments too. But yeah, so good news there is it seems like it's kind of all win. That doesn't happen very often, but yeah. So any questions or comments on any of that?
Nope.
So
Get it merged.
Go ahead.
Let's just get it merged.
Sure.
That's good.
Is that one that is a candidate for backporting? It doesn't change any on disk stuff.
I'd let it bake and master for a while, but eventually we could do it.
Sure.
But I'd probably only
Nautilus
go
would
back
at
to
least
Nautilus.
be nice.
Yeah. Go back further.
All right. So next thing, recovery settings. I have been looking at recovery for the last couple of days. Primarily what happens in CPU constrained scenarios. But what one takeaway that I found from this is that our current recovery settings are very, very, very much optimized toward not impacting client I/O on hard drives. And on NVMe, it's really, really awful. There's kind of like an upfront cost. As soon as you go into recovery, it's like maybe 10 or 15% on the test cluster I've got. But recovery is so slow compared to the rate that you can get that you can ingest data in. That you can almost make it kind of stall recovery. It doesn't quite stall it, but it kind of almost, for all intents and purposes, is recovering so much slower than data ingestion that it's not good.
That's more a property of the kind of test you're running, right? If you're saturating the cluster, absolutely, then that's the kind of behavior you're going to see. But in a use case where the cluster is not getting as much load as it can possibly handle thrown at it, probably not going to overrun those kinds of the speed of recovery.
Well, but one of the problems, Josh, is that on NVMe you can write so many objects that people end up with a lot of objects, right? So you could write 16K Rados objects easily at 50,000 write IOPS to a small cluster. Far more if you have the CPU available, right? You can end up with a cluster that's got, maybe like 100 million or 200 million objects.
Sure.
Our default recovery settings on this cluster that I've got, it's like 12 NVMe drives across 3 nodes. recovery with our default settings was happening at 1,000 objects per second. So you imagine losing one of those, losing like 10 million objects, and you're recovering at 1,000 per second. I mean, it's a really long recovery time, even if you don't have a client I/O workload happening.
Yeah.
Um,
So when you bumped up to like the max backfills and max active, were you seeing the speed increase sufficiently?
Dramatically. Right now, the setting I've got, after just playing around with it, is I think I've got OSD max backfill set to 16, and the max active recovery is set for 64. And with those settings, the average ratio of client I/O to recovery I/O was split like 70% client, 30% recovery, roughly, is what I was seeing when I was recovering objects, with a client I/O workload happening.
This may be an aside, but I would expect that we would want to keep the max backfills at a small number and proportionally increase the max ops. So instead of having 10 parallel backfills doing 2 ops each, have one backfill doing 20 ops. Same number of ops in flight, but you're working on one PG, so it completes faster.
Sure. Yep, I believe it. I agree. That seems very much correct. So increasing only the active recovery allowed me to get to the point where I had about half of the OSDs participating. The only way to push that further was increasing the OSD max backfills. I guess that sort of makes sense. I didn't really actually fully understand how this worked when I started, but not all can participate with each other right now. So not all OSDs will participate in the overall recovery with our current settings.
It seems like maybe what we really need to do is change the OSD max recovery active so that there's an HDD and SDD variant so that we can make the default on an SSD be like 30 instead of 3. Does that sound right?
You could do that. I would like to take a stab at doing adaptive recovery. I think I can make it work.
What does that mean?
Adjusting these on the fly based on trying to figure out the proportion of time being spent currently on client versus recovery I/O.
Yeah. Yeah. I mean, if the I think the nicest user experience would be to say, I want 30% of my, I don't know if it's bandwidth, IOPS, whatever, 30% of my capacity, my throughput to be devoted to recovery.
What I'm thinking is we look at the overall time spent on ops in the last interval for client I/O and recovery I/O. And then we try to tune that to some ratio of times. But if there's not enough client I/O to hit some kind of threshold that we've set, so we always give it a little more than it wants. We always leave a little capacity. But if that's not using it, then we allow the recovery to kind of go beyond where it normally would be kind of limited to. Sort of kind of like how some of the OSD memory target stuff works, but it'd be a little different.
I think the key is understanding, I don't know if you can tell what the slack is. Like say I'm doing well, you have to measure wall clock time, I guess, but I'm not sure where that happens.
Yep.
Where would you do it?
Yeah.
In the op TP threads? They're like end threads.
That's what I don't know is where to tie it in,
sure.
Where to start looking at the recovery op, how much aggregate time in the last interval we spent in recovery op versus how much aggregate time we spent in the last interval in client ops.
Yeah, it's tough to account for that kind of exactly, especially when you like have BlueStore in there with batching up multiple things together. And
Yeah.
RocksDB in the background potentially being bottlenecked by a CPU.
Yep.
I'm kind of wondering
Yeah.
if we could do something more coarse-grained as a heuristic, like maybe looking at queue depths within the OSD and BlueStore, and kind of backing off of recovery. We start seeing those increase past a certain
That
point.
could possibly work.
There's probably some other heuristics we could do that are similarly simple like that, but just thinking it's a tough road to go down to try to really measure exactly how much time or resources we're spending on a particular op.
How does the queuing work for recovery versus client I/O? Do we have kind of those already going down different paths?
They're all going down the same OSD app work queue.
Okay. And we don't have anything right now that differentiates those in kind of a useful way?
I mean, they're different structures and they're handled in different paths once they get out of the queue, but they're being queued in the same place.
Yeah. Okay.
And they've got different priorities associated with the messages. And once they go to the replica side, then they're just, for recovery, we're just doing them in strict order. Kind of bypassing the queues over there, almost.
Okay. Well, so yeah, I guess early stages, right? But maybe we can do something here.
Yeah.
I'm hopeful that we can.
I think it would be
I'd
nice to
much
be able
rather
to
do
do
that.
something like really simple that we could potentially backport as a first step, and then maybe, if possible, we could make that a little bit more intelligent as a second step. Like maybe the simple thing could just be increasing the max backfills and max active to some higher thresholds based on some very simple measurement of how busy the OSD looks right now.
Yeah, could you start with something as simple as looking at the device class and coming out with the base starting points based on that?
Yeah, I think that's step 0. Like say you're suggesting having a separate SSD versus HDD default for the max active, max back.
I hate that though, because of what I've seen too many customers get burned by not setting those, like thinking they've set those right, and then like having the base value and different like HDD and SSD values override them, or the other way around. I forget how we usually have that work, and then they have it set differently than they think they do.
Yeah, on the flip side, then the default behavior on a NVMe be less terrible, right?
Yeah, I think like most people aren't changing the defaults, so if we can get the defaults right, then improve the docs so that it's very clear about exactly what the settings do.
Yeah. Different NVMEs might behave differently too, though, right? I mean, if you've got like a really crappy slow one, you might not.
We just have to.
What?
Yep.
Yeah. But to start with something.
Just push it all up the dashboard team. That's where you take care of it.
Oh, make the OC smart. My crusade. So, yeah, the only other thing I have in this is that, so I have been doing a lot of CPU limited testing, and what happens when you're CPU limited is not only is the client I/O slower during compaction, or sorry, not compaction, during recovery, but then the recovery takes longer. So it's like a multiplicative effect, right? You're spending 2 or 3 times longer in recovery, but your throughput is also like half what it is if you had more CPU. So this is kind of a commentary, I guess, on why it really is irritating to be CPU limited on the OSDs, but that's part of it. Which I guess maybe also. Oh, but having said that, when you're CPU limited, regardless if you're using like half a core, 1.5 cores, or 2 cores, or whatever on the OSD, I saw the same ratio of client to backfill traffic, roughly. It was really close. So at least one good thing is that we're not seeing like different ratios of client to recovery traffic depending on how CPU constrained your OSDs are, which I was worried about. So that's a silver lining. Yep. I guess one thing I didn't put down here is I'm looking at OMAP stuff too, but that's a different topic, and maybe I'll talk about more next week. So I think that's it for my stuff. Looks like you've got some stuff in there, Sage.
Yep. So we did the secure mode. It all merged in time for Nautilus, but it was marked as experimental. But then fully
You're
enabled.
muted.
Am I muted? Hear me?
Still muted.
How about now?
Nope.
All right, hold on.
That was weird. I could hear him.
Oh, no, maybe you're fine and I'm not okay.
How about now? Is that better?
I can hear you at least. I'm not sure if Mark is having something separate issue.
Okay. Could you hear me before?
Yeah.
Yeah,
Okay.
we can hear you, Sage.
Okay. Mark looks very confused. All right. Okay, so the secure mode stuff. Can you hear me, Mark? No? No. Well, anyway, it's all been enabled in master for like 2 months, 3 months, however long it's been. And we fixed our first bug. And that explains the sporadic failure we've been seeing, but otherwise everything looks good. So I think the only thing really blocking us turning this on by default, not to turn on, well, making it not experimental in Nautilus and changing the default so that your connections to the monitor are secure, is that we don't have any numbers about how much slower it is when you use secure mode versus unsecure mode. But I really want to talk to Mark about this, so let's wait a second here. Any luck, Mark? No.
I've got it back. Sorry. I didn't hear a thing.
There it is.
Stage.
All right. Okay. So the secure mode was merged for Nautilus, but marked experimental in Nautilus. It's been enabled in master. It's all been fine, or at least we thought, except there were these sporadic mon-down errors that we're seeing in QA that it turned out were due to a secure mode bug. That's fixed. They now go away. So feeling generally very good about it. The only thing that's really left is waiting a little bit for it to bake a bit longer in master before backporting that fix and then turning it on in Nautilus. But before we do that, we need to have some numbers that say how much slower and or how much more CPU it's going to take to use secure mode. That it's a bit of a maybe. I mean, well, we want to know what the impact is for OSDs. By default in Nautilus and in master, it's actually only enabled by default for the monitor communication. Just so your mon commands are always encrypted, and when you set a authentication key or whatever, that's never submitted in the clear. So that will be the default. So I think even without performance testing, the default behavior isn't going to impact anyone. But still, the first question every single person asks about the secure mode is how fast or slow is it? So we really need to do that. So I just wanted to bump that up your priority list because I think it's more important than all the adaptive recovery stuff, just to get this tied up. Otherwise we've invested all the work implementing it and nobody can actually use it yet. The other thing, though, is that somebody, I forget who, just did a similar comparison, but just with the regular mode between
It was Roman.
that was Roman between Mimic and
Yeah.
Nautilus, and there is a difference. There's a bit of a impact in Nautilus, presumably related to the complete. There's like a huge refactor cleanup rewrite in Messenger 2 code, not the Messenger 2 code, but the async Messenger code. Sure if it affected, yeah, even when you're talking V1, I think. I'm not sure if it affects V1 or V2, also if it's only V2. Either way, there is a big refactor. So I think we also just need to do whatever setup it is that is basically pushing as much data over the wire, and then do some perf work to figure out where the CPU time is being spent, look at some profiles, whatever, and see what optimizations we can make. There hasn't really been much attempt to, nobody's looked at that yet with the new code, so we don't really know where time is being spent. I'm not even sure we spent much time. No, I guess the old code is pretty well optimized, but we haven't done that with the new code yet. So, yeah. Do you have a preferred mode, or you just like use memstore or something on the back end to do this with like a read workload, or I don't know what you would. Do you know what you would do in this case to sort of isolate the CPU usage for network stuff?
So I don't remember who was doing it, but someone was doing some kind of like messenger only testing. There was something recently that was written for it. I don't remember what it is. I've never used it.
Right.
I think that was Roman Pinyev. I think
that was Roman.
doing that.
Okay.
Yeah, with Fire,
I
think.
Okay. So we should maybe reach out to Roman. Maybe he can help us on this.
Yeah.
Be aware
He's
the
actually-
only FIO numbers I saw were very, very unlike messenger throughput test numbers we got in other circumstances. I don't know if they figured out why, but he had some demonstrations and they seemed implausible compared to everything else people have run.
Greg, do you remember what was odd about them?
Just like the numbers, I think were half the speed we got in like OSD messenger testing or something. I don't remember exactly, but
Okay.
I never looked at like the implementation or anything, just the raw number throughput. There was something making it not useful. And I don't know if they ever figured out why.
So, we could do memstore. Probably would want a version of memstore that used the vector stuff that I did, because memstore itself is not particularly fast. Getting that FIO thing working would be good, though. If that actually showcased reasonable numbers, like if we got good numbers out of it, it'd be way easier to actually test the messenger that way.
I mean, I think even if you just did, like on the Incerta, just did a streaming workload, looked at the CPU usage, and then repeated the same test and looked at the CPU usage.
Yeah.
Like what you'll probably see is that the throughput is about the same, but that the CPU usage is like 10% higher or something. And that would be like, in the case where you have CPU slack, then use this much more CPU. And then you have to construct another test where you are CPU limited. And then, or something, I don't know. Because the micro benchmark is going to be helpful for measuring the difference between Mimic and Nautilus, or secure mode, not secure mode, or whatever, and maybe doing profiling, but it's not going to reflect what a real workload is going to look like. And what people really want to know is like, I have my cluster, if I just turn this on, how much slower is it going to go? It's kind of a challenging question to ask, but we can like pick something that's something sort of, hand wavy representative at least. So I wouldn't get caught up on like trying to have the perfect macro benchmark. I would start with just doing a macro benchmark and just see.
Yeah.
That's closer to what a user would be anyway.
Yeah, the first step will be getting the CVT Messenger 2 stuff working, figuring out why that was breaking. So
Yeah,
go back
yeah,
and do that, and
yeah.
then we can move from there. Once that's done, then it'll be easy. Once we can just switch between them, then it'll be easy to do a constructor test and just see how it does.
Yep, as long as TBD can still run Mimic, because we'll want to do a Mimic Nautilus V1 comparison probably too.
Sure. Although, do
You
you
can
really
start. You can
want?
start with that even. You can start with that even, just because that might even be step 0 is just to see if there's a regression on the V1 performance between Mimic and Nautilus. We can repeat what Roman saw.
Would you expect a regression in V1?
Yeah, the code was refactored so that
Okay,
the protocol implementation was factored out of the async connection code, and so
I
there are a
see.
bunch of like out calls or whatever. Hopefully it doesn't
I'd be a
really matter,
little,
but if it's there, then we should try to understand it.
yeah, I'd be a little concerned that there's enough other changes between Mimic and Nautilus that it's gonna be hard to strictly.
Yeah, that's probably true.
I mean, we wouldn't be able to
Yeah, you're right.
necessarily attribute any regression just to this.
Yeah, that's true.
I guess what I would maybe want to, it seems to me like maybe, an easy, straightforward comparison first would be just Nautilus with V1, V2 and
Yeah,
see
yeah,
how that
yeah,
is. And then,
yeah. Do that. That's what matters probably more anyway. Okay.
yeah. It'd be good too if when we do stuff like this, if we're kind of looking at this while we write it too, right?
Mm-hmm.
Rather than
Yep.
kind of after the fact figuring out what it's doing.
Yeah, it'd be
Well,
great if we could not have a performance backlog, but rather consider it as part of the process. I think the work that Crimson folks are doing in terms of trying to get performance into the CI and running as part of the regular tests will help a lot with that.
Yeah.
Yeah.
Yep. Okay.
Cool. Well, anything else, guys?
That's it for me.
I've just got a couple of quick questions, Mark. I've been continuing to work on all flash based performance stuff, and I'm down to the point where I'm looking really hard at the difference between, in IOPS between the 64K IO and 4K IOs. And when I do the math, we're talking, we're seeing a tenth at 4K over what we should based on the 64K numbers. Understanding some of that gets down to what's happening at the SSD. I'm trying to get a grasp of what's happening from a write amplification perspective as we go through the wall and all those bits. Do you have any thoughts there? Material I can take a look at to understand what's happening from the amplification perspective, and also any particular things that might be worth tuning for an all-flash environment that I may not have thought about.
What's the workload?
So I've got several that I'm applying to. I'm focused around media and entertainment, but this shows up also in the IO 500, which we have a result out there actually that I posted this week. So,
I guess I don't know exactly what IO 500 is doing.
yeah,
But like,
it's got a big chunk of sequential and then a chunk of random that it does very small random workloads, and that's where I'm seeing the biggest drop off is the small
okay.
random.
And in that workload, is it high concurrency or low concurrency?
I would say it's somewhere in the middle based on the way the test looks at this point.
Okay. And RBD or CephFS or
Yeah, so I'm doing everything with CephFS.
okay, CephFS. Okay.
Yeah,
And lots of files or one file?
lots of files.
Lots of files. Okay.
Yeah, hundreds of thousands.
Hundreds of thousands of files. Okay. Um, so I'm not as much of an expert on CephFS. We might want to talk to Patrick about it some, but I would be concerned about what kind of is when you have hundreds of thousands of files that you're writing to simultaneously, what the effects of that would be. Um, that might be kind of a first place to start. I imagine that you're going to run into different kinds of constraints here than you would with if you were just doing like 4K random IO to a couple of files on like an RBD volume or something, or multiple RBD volumes.
I
So
you're somewhat right in what I'm seeing, but the pattern is the same because I do have some tests where I'm doing small numbers of files with random 4K IO, and I still see that massive mismatch in IOPS from what I would expect. And that's what I'm trying to get my head wrapped around. What kind of right amplification factors should I be looking at and expecting to see, and then what am I missing? That kind of thing.
and what kinds of numbers are you seeing versus, and what are you kind of trying to or expecting to see?
Yeah, so if you just break it down to the raw math on what's happening at the 64K level, it's like 2.8 million IOPS. And when I look back at it from a 4K perspective, we're only seeing about 285,000 IOPS for doing the same, roughly the same. So I know the numbers don't exactly line up here, but it's a much bigger delta than I fully expected to see.
Okay, so 285,000 IOPS. How many devices?
That would have been against 40, 50 devices, I think, 50.
Okay, so you're on the order of like 5,000 IOPS per device.
Yeah, something like that.
Replication?
3.
Okay,
So it's
so
it's playing into it for sure.
so 15,000
Yeah.
really to each one. 15,000 is kind of getting up into the realm of where if you were CPU limited, that would be a not an unexpected BlueStar result. Are how many devices per node?
10.
10 NVMEs per node. And how much CPU per node?
It's so there's SATA SSDs, so that plays
Oh,
in
okay.
as well, right?
Okay.
Sorry, it was 120 devices, not 50. So it's a single 6142 per node.
Sorry, how many
When I'm watching,
cores?
you would ask that. I don't know.
Let's see. I just looked it
Well,
up. 6142 has 16 cores. So, and there's one of them or two of them?
One.
One. Okay, so you have 1.6 cores per flash device.
Yep. Turn on
All
HT,
right.
disable all the remediations.
Yep. Okay, so yeah, so 1.6 physical cores, 3.2 HT. When you
Yep.
when you count that, you get 3.2. And 15,000 write apps per device. I think you're in the right ballpark,
Okay.
honestly.
Just
I'm
feels
guessing
like
your CPU
feels like
limited.
there should be. CPU doesn't. We're not peaking anywhere, and that's
Interesting.
why. Yeah, it's part of the reason I feel like I'm sucking wind, that I'm missing something somewhere.
Huh. How close are you to hitting your CPU?
At max, I've still got 35-ish% left sitting there.
Okay. Interesting. How fast can those devices do writes? Like OD sync writes straight to the flash drives.
I would honestly have to go back and look at my numbers, but it's reasonable. It's the Intel DC3 4510s. I don't even know where I've got those numbers stored, but we're not getting close to that threshold, which is why I'm pretty sure I've got some more I can do to these devices.
Sure. Yeah, at some point you'll hit like SATA or SAS or whatever limits.
Yep.
It's been a while since I looked at that on fast devices, so I don't remember really kind of how quick you can really go on them. But yeah, you could try.
Oh, go ahead.
What was that?
I
was just going to say you could. Oh, go ahead.
I was just going to say that the PRs that you've got sitting out there look like they could potentially play into this as well. So some of the stuff you talked about first of the call.
They should lower latency at the very least in a scenario where you've got lots and lots of traffic.
Yep.
I don't know that they necessarily will improve CPU utilization much, but maybe they will. I still saw like on our Incerta nodes with P3700 NVMe drives in them, to get 40,000 write IOPS on an OSD, it's using 10 cores. So it's still burning a lot of CPU to pull that off.
Yep.
Which is why I'm surprised that you're able to get 15,000 write IOPS with like 3.
Yeah. What kind of cores are those that you're doing that with? Are those Skylake?
Those no, they're old. They're 2.3 gigahertz Haswell.
Okay, so that actually matches some stuff we've seen on another system, where the guy's peeking out the CPUs way before I've got. The Skylake seem to be much better at this.
Oh, that's interesting. Yeah, I don't have anything real recent to test on, so we're the new nodes we're getting are going to be great, but I haven't I don't know how much IPC improvement you really see, so that's good to hear.
Okay. Well, I'll keep tinkering with it and seeing what I can find, and I'll let you guys know as I see anything.
Cool. Sounds good. I was just going to mention you could try running it through one of the OSDs through either Adam's wall clock profiler or my wall clock profiler. Adam's is faster, but it's C based and it's a little harder to get running. Mine just uses GDB, so it's super slow, but it as long as you have like Python and GDB installed, it usually works.
Okay.
I can link that.
That would be great.
It is in the chat window.
Got it.
So that will make everything like super slow, but it might tell you where in the code things are waiting, and then like if you see it that like the KV sync thread isn't like super busy, then that might tell you you're waiting IIO. You can like look at the bstore AIO thread too to see if that's like 100% busy. Also, if you see IO submit taking a lot of time, then that means that IO submit is blocking, and that also usually means that it's like saturated the device and the queue depth has been kind of like reached, and now IO submit's just blocking. So that it'll give you some indication of like what kind of is going on.
That is fantastic. Pretty geeky for a non-developer, huh?
Yeah. If you do that, I'd be very curious to see what your results look like. I always like seeing kind of different setups and where we have different bottlenecks.
Yeah, I'll see if I can get it run at that in the next week or so.
Cool.
Thanks.
All right. Well, we're out of time, guys. So have a good week. Talk to you later.
Thanks, everyone. See ya.